All right, let's jump straight into this explainer. Today, we're putting you directly into the pilot's seat. We're going to experience the exact moment-by-moment mechanical procedures of flying a complete circuit, using real standard operating procedures. We aren't just talking broadly about flying here. We're breaking down the literal physics and the specific, calculated actions it takes to get an aircraft into the sky and bring it safely back down to Earth.
You know, it looks incredibly smooth from the passenger window, right? But have you ever wondered what a pilot is actually doing step by step to make that happen? Well, we're going to demystify the intense mental and physical calculations happening inside that cockpit. We're taking what might look like a totally dry aviation manual on paper and translating it into your firsthand flying experience. Get ready, because the cognitive load is going to be absolutely massive. Okay, first up, line up and take off. Picture this. You've rolled right onto the runway centerline. Your oil temperature and pressure are in the green, and now it's time to unleash the engine. You smoothly push to full throttle. As your speed hits exactly 45 miles per hour, you gently apply backward pressure on the control column to lift the nose. And then you must physically feel the plane unstick from the earth at precisely 50 miles per hour. It's a highly calculated maneuver based purely on the aircraft's exact aerodynamics. Now, to pull that off takes some serious raw power. The very second you hit full throttle, you have to dart your eyes down to the dash and verify the engine is roaring to a minimum of 5,200 RPM. Because if you don't hit that magic number, well, you simply don't have the thrust to safely unstick at 50 miles per hour. Moving right along to phase 2, climbing and the crosswind leg. All right, so you're airborne and accelerating to a steady 60 miles per hour. This climb-out sequence is a perfect example of the crazy multitasking pilots do. At exactly 300 feet above ground level, you literally tap the brakes. Why? To stop the wheels from spinning and creating unwanted gyroscopic forces. By 450 feet, you're quickly checking that your airspace is clear left, front, and right. And right as you hit 500 feet, you initiate a really precise 10 to 15 degree banking turn onto your crosswind leg. So what this all builds up to is establishing what's called a normal circuit. Basically, it's a standardized flight pattern flown at exactly 700 feet above ground level, holding speeds between 60 and 70 miles per hour around the airfield. To maintain this, you're constantly playing with your throttle, balancing it between 4,600 and 4,800 RPM, all to counter the total weight of your specific aircraft and whatever the outside air temperature happens to be. Physics is practically dictating your throttle hand every single second. Next up, we hit phase 3, the downwind leg. Now you are leveled out and flying parallel to the runway, just in the absolute opposite direction. This is the busiest phase of the flight. Just look at the sheer density of these standard operating procedures. While your hands and feet are physically wrestling with wind and gravity, your brain is mentally juggling this massive checklist to make sure your alignment is safe. You aren't just flying the plane, you're executing a rigid, high-stakes algorithm in real time. Specifically, before you can even think about turning back toward that runway, you have to continuously run through this vital 5-point check. Height, speed, direction, power, trim. You are settling into this downwind leg, constantly cycling through these 5 parameters and broadcasting your intentions over the radio, all without losing your setup for even a fraction of a second. All right, bringing us to phase 4, the base leg and final approach. As the runway threshold pops up at your 5:30 clock position, you drop your altitude by 150 feet and roll out onto finals. Here is where you have to dynamically adjust your engine power based entirely on what the wind is doing. If it's calm, you drop the power to about 3,500 RPM. But if you're fighting strong headwinds, you have to maintain a higher RPM just to push through it, adding roughly 200 RPM for every 5 knots of wind. And the absolute golden rule here, never drop your RPM below 3,000 on finals, or your approach becomes dangerously steep. Now, through this whole stressful final approach, you have to maintain exactly 60 miles per hour. And I mean exactly. This isn't just a suggestion, it is the literal mathematical key to a safe landing. Nailing that 60 miles per hour and noting your precise RPM at 100 feet to go is what allows you to correctly assess the float period right before you touch down. If your speed is off even a little bit here, everything that follows is going to be a mess. And finally, phase 5, flare, touchdown, and rollout. The ground is literally rushing up at you now. As your speed drops off, you will physically feel the aircraft start to sink out of the air. It's a very distinct dropping sensation. To arrest that sink rate, you have to gently rotate the nose upward. This is called the flare. You're trading your remaining forward speed for lift, slowing your descent enough to land firmly on the main wheels, completely closing the throttle only after you've made contact. But here's the kicker. There's a hidden force you're fighting this whole time. See, landing isn't just about going down. That massive spinning propeller at the front of the plane acts exactly like a gyroscope. So any change in power, like pulling the throttle back to land, creates yaw. It's a twisting force that violently pulls the nose off center. You have to anticipate this physics phenomenon and instantly counter it by pushing the rudder pedals. You're basically constantly fighting the engine's desire to twist the plane off the runway. Now, throw a crosswind into that mix and it gets wild. The manual actually states that if you just straighten the nose with the rudder, you'll drift laterally right off the runway. So to counter that drift, you have to apply opposite aileron. You literally bank the plane into the wind. This means you intentionally touch down on one specific wheel first. You land on the wheel of the lowered wing and only then let the other wheel drop. You are deliberately landing crooked just to stay straight. So as we wrap up this explainer, I want to leave you with this thought. From countering gyroscopic yaw with your feet, to banking into the wind with your hands, to perfectly timing a 50-mile-per-hour unstick speed while verifying a 5,200 RPM threshold with your eyes, stepping into the cockpit means mastering a relentless,